All right, good morning. Sorry I had to mute. Those announcements were a little bit loud this morning. Just giving people a chance here to get logged in and connected, and then we'll get started. A few things to talk about today. So here's kind of our agenda. So the Chapter 11 test was supposed to be done last week. For your group, Friday would have been the best day, but it was open for the weekend. So if you haven't done that, make sure you get that taken care of today. I may have to go back in and reopen it. Again, if you didn't score well and want to retake it, you will need to schedule a time with me to do a Zoom meeting. Wednesdays are fantastic for that. Just send me an email, send me a message through Schoology, either way, and I will set up, when you send that message, make sure you specify a time and a day. I've had people say, well, can we do a Zoom meeting? And then not give me a time or a day to do that. So best to say, hey, can we meet on Wednesday at 12:30 or whatever time, whatever time works for you. And then I will either set it up and send you the link or say, I've got class that time or I've got another meeting or whatever. But I am more than willing to work with your schedule. We are going to start 12-1, day 1 today. Basic probability events. There is available a new packet. I will also put it online. So it'll be in Schoology shortly after class today, so that you can use that. And then you'll have time to work on a few things. And actually, I need to add one more thing in here. You will have also a warm-up, note check, and homework. And that is all on Schoology. It would be great if you could get that homework done by tomorrow, by the end of the day tomorrow. Missing work from Chapter 11B is due by Wednesday, November 4th. And that way it can go on your 8-week progress report. After that, missing work becomes closed down. So if you have questions, again, email. You could stay after I'm done notes today. And let me know. Obviously, if something's going on, or you had an extended illness or something, and you need a little extra time, we can certainly work that out. All right. All right, let's get to work. So your warm-up is going to look like this. There are going to be 2 questions. Each question is going to have 3 parts. The first part is changing from a fraction to a decimal and rounding to 2 decimal places, the nearest hundredth, if necessary. And the second part is changing from a decimal or a percent to a fraction and then reducing it to lowest terms. So a couple of things I noticed from yesterday's class, that when they did this, question 2, they did not write, some of them did not write as fractions. Okay, it says write it as a fraction, so that's going to be the correct form for the answer. If it's not in a fraction, it can't be correct. Otherwise, again, if you have questions, let me know. So you'll have a chance to do that warm up, and I'll show you what that is going to look like. Actually, I'll show you right now in Schoology. So in Schoology, there's the new folder. And when you open that up, there's today's work. And in there, actually, I want to get rid of this because that's yesterday's. You guys don't need my other classes Zoom meeting. But there's a warm up, there's a note check, and there's homework. And if you can see here, it says you must make a submission. In other words, you have to do the warm up before you do the note check. And then you have to do the note check before you can do the homework. And that's the way it's going to, that's the way that's going to be set up from now on. So there's a definite order to do those things in. All right. Moving on. So I'm going to give you a few minutes to look at this explore and reason, couple of questions. Dealing with a little bit of probability. So Allie spins the spinner and draws a card without looking. So the cards are face down, so she can't see which card she's getting. She gets a 3 on the spinner and draws the number 3 card. She then takes that number 3 card and puts it away somewhere. Then she spins the spinner again and draws another card. So we're answering a couple of questions. So is it possible for Allie to get a 3 on her second spin? Yes or no? Explain. Is it possible for her to draw a 3 for her second card? Yes or no, and why? And then the second question, how does drawing the 3 card on her first draw affect the probability of getting the number 2 card on her second draw? So I'm going to try to leave that up as best I can. Actually, maybe I'll go to a full screen mode so that you can see the whole thing. There we go. And it's better anyway, I think, a little bit. All right, so I'm going to give you a few minutes and let you work answering those 2 questions. All right. So for those questions, some possible answers. Allie can get a 300-second spin. She could get actually any of the numbers 1, 2, 3, or 4. But she cannot get a 3 because she removed that card after her first draw. So her only possibilities for her card would be 1, 2, or 4. As far as drawing the 3 on her first draw, affecting the probability of drawing a 2. On the first draw, the probability of a 2 was 1 out of 4, or 25%. On the second draw, because there are only 3 cards left, the probability increases to 1 out of 3, or 33.3%. So there's the answers there. So as I said, we're going to talk about probability events today. How does describing events as mutually exclusive or independent affect how you find probabilities? And we'll actually talk about mutually exclusive today and independent on Friday. So obviously this is day 1 for 12/1. We'll have a day 2 for 12/1 on Friday. I'll give you a chance if you're writing that down. All right. So one of our goals, I can find the probability of events and combinations of events. So looking at multiple events as we move through. So some quick vocabulary. An event, when we're talking about probability, is something that has some possible outcomes, but we don't know which one will happen for sure. So an event might be flipping a coin or rolling a die or drawing a card. Those would all be examples of events. When we talk about events, one of the major things that we look at for probability is something called the sample space. The sample space is all of the possible outcomes of an event. So here we have a die. So if we roll a die, the possible outcomes, the sample space would be the numbers 1, 2, 3, 4, 5, and 6. Mutually exclusive events are events that cannot both happen at the same time. So for instance, if we roll a die, rolling a 1 and a 2 on the same die cannot happen with one roll. So those would be mutually exclusive. And the key there here is the word exclusive. It can't happen. And the last definition, complement. And now that's not talking about, hey, Mr. Gingrich, you've got a nice shirt and tie on today. This is a complement of an event. And it's the set of all outcomes that are not included in the event. So if I have the probability, and we'll use this P and then parentheses, probability of rolling a 3 on the die, then its complement would be the probability of not rolling a 3. And finding probabilities for complements can be very easy if you know the probability of the actual event first. All right. So anytime we're trying to find a probability, the probability of some event happening is the number of times, the number of favorable outcomes, or the number of times that event happens divided by the total possible number of outcomes. So if you roll the die one time, what is the probability it will land on 3? So you can either unmute yourself, or if you want to go to the chat. And what I'm going to do is I've set the chat up so that it will only go to me. So you don't have to worry about someone else seeing, and I don't think you can see it if I pull it up here. If you can, I'm sorry. And we've got, or you could unmute yourself, like I said, and just shout out your answer. But it looks like we already had an answer on the chat, and it looked very good. So the probability, roll a 3. So the number of favorable outcomes, how many spots on a die have a 3? Well, that's 1. And how many total possible outcomes are there when you roll a single die? There are 6. So 1 out of 6 for that one. What is the probability that you will not roll a 2? And it looks like we've got all sorts of answers coming up. Yeah, and they all look good. I like it. So again, a couple of ways that you could do this. Yeah, they're all right. I love it. I love it. The numbers on a die that are not a 2, well, that would be 1, 3, 4, 5, and 6. So there are 5 of them of your 6 possibilities. Another way that you could calculate that is you could take, thinking of the complement, you could take 1 minus the probability that you roll a 2. So it would be 1 minus 1/6, which is also 5/6. So just another way, and in this case with the die, it's probably just as easy to do it this first way and not even think about the complement. But for other probabilities, knowing that complement is going to be very helpful. All right. We spin the spinner one time. What is the probability it lands on a shaded region? And just for clarification, I'm counting those 3 as being shaded. Yeah, so just because it's, the one is shaded a little bit different color, I wanted to clarify that, and I think that helped out a few people. So the probability spin shaded, there are 3 shaded spaces and 7 spaces in all, so 3 out of 7. The last question on this part, what is the probability that you land on a white section or a non-shaded section? All right, all sorts of people want to jump in on that one. Excellent. And again, they all look very good. So again, 2 ways to think about it. You could just count. There are 4 white spaces and 7 total. That would be great. Or you could take 1 minus the 3/7 to get 4/7. Either way gets you to the right answer. That's one of the things I like about math. There's usually a right answer, but there are usually more than one way to get there. All right. So one way that you can model events is with something called a Venn diagram. So with a Venn diagram, the first thing you do is you start with a rectangle. And here we're talking about rolling a standard number cube, a die. We're going to let E represent the event that you roll an even number, and T represent the event that you roll a 3 or a 5. So what we do is event E, we're going to use a circle, and it doesn't have to be a circle, but in general, Venn diagrams use a circle. So that's going to be our event E. We roll an even number, and I'm actually going to label everything in here. My even numbers on a die, 2, 4, and 6. And then we have event T. That was rolling either a 3 or a 5. If there are outcomes that could occur in both, we would let those circles overlap. And then one thing you might also want to do is label all the other possible outcomes. So we could roll a 1, and that's not in either set E or T. So this is a Venn diagram that show events E and T as a subset of the sample space S. All right, and we can use that to answer some questions. So you roll a standard number cube, a die, 1 time. What is the probability you roll an even number or a 3 or a 5? If I use my event labels, that would be the probability of E or T. Yeah, so it's going to be 5 out of 6. And if we go back to that Venn diagram, there are 6 possible outcomes. 5 of them are in the circle E or the circle T. So what is the probability that you do not roll an even number? So now we want all of the possible outcomes that are not in E. So there are 1, 2, 3 that are not in E. Again, I'm guessing most of you wouldn't need to use the Venn diagram. You would know that there are 3 numbers on a die that are not even, they're odd, 1, 3, and 5 out of the 6 possible. And then the great thing to do if you're using fractions is to reduce. And yes, you will want them reduced. That's why our warm-up has some reducing of fractions in it. All right, a couple of definitions or formulas. If we have 2 events that are mutually exclusive, the probability of one event or the other happening is simply the sum. Take the probability of A happening plus the probability of B happening. And that's if they're mutually exclusive. That's kind of a big deal. The probability of A and B happening is 0. If they're mutually exclusive, they cannot both happen. All right, a quick write. I'm going to do it this way. I think it'll be a little bit easier. So take about a minute. What is the difference between using the word or and using the word and in probability? And I am going to mute. I'm going to mute and turn off my video and give you a chance to write. All right, so what is the difference between and or? All right, a couple of chatters in there like that. Using or indicates that it's one or the other. Using and indicates that both. Okay, excellent, excellent. Two great answers in the chat. So if you chatted, I appreciate that. I'm going to write kind of the way that I think about it. So, or means at least one event happens. And means both events happen or occur. So that's the difference between and or. All right. So a couple of notation pieces. One of the nice things about probability is we can write the probability in some pretty short shorthand notation. Union is another way to write or. So that is the probability that event A or event B occurs. And so we use, again, the capital P for probability, parentheses, A union B. And the union symbol is the U. So union U makes kind of makes sense. The intersection is the probability that A and B happen. So, and instead of writing the word and, we could use this upside down U, which is called intersection. So we have the probability of A intersect B or A and B. And you'll hear those words used kind of interchangeably. All right. A couple of more examples, and then we'll call it a day for math. A box contains 100 balls. 30 of them are purple, 10 are orange. If you select one ball at random, what is the probability of the following events? So what is the probability that we get purple or orange? So if I just draw one ball, could I get both a purple and an orange? Yeah, no, it can't get both, right? So those are mutually exclusive. So one way you could think about this is, what is the probability that I draw a purple ball? Well, there are, oh, there we go. A couple of people, yeah, there are 30 out of 100 balls that are purple. And then what about an orange ball? Yeah, excellent. And we can, because they're mutually exclusive, we can add those probabilities. And so I'm gonna wait and reduce at the end so that I have the same denominator. So add the numerators, 30 and 10 is 40. Denominator stays the same, and then reduce. And I'm going to show you one of my favorite, I don't want to say tricks, but one of my favorite reducing rules. If both numbers end in 0, cross the 0 out. And then see if there's a number that divides into whatever's left. In this case, 2 will divide into both 4 and 10, leaving me with 2 over 5 as a reduced fraction. All right. Okay. What is the probability of not getting purple and not getting orange? All right, got a couple of answers there already in the chat. Excellent. Good, 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 good. They all look good. Again, one thing we want to make sure we do is reduce. So if we start with 60 over 100, right, because 40 were either purple or orange, so 60 would not be, and then reduce. And some of you went right immediately to 3 over 5, which is fantastic. All right. A couple to try on your own. Again, what I think I will do is give you just a minute or two. I'll mute myself here in a minute so you don't have to listen to my voice. But Jackie has a sock drawer, and there are 7 white socks, 9 black socks, and 5 socks that are solid colors other than white and black. So what is the probability that Jackie picks a sock that is a colored sock? What is the probability she picks a sock that is black or white? And what is the probability that she picks a sock that is black and white and black? Sorry, didn't mean to read that the wrong way. So I'm going to give you, again, about a minute. Go ahead and give these a try, and then we will come back together and see how we did. All right, I kind of lost track of time. I think I've given you a minute though. So what do we think? What is the probability that she picks a sock that is colored? So probability of a colored sock. Now let's see. There are 5 socks that are solid color, 21 total socks. So 5 out of 21. That sounds fantastic. What is the probability that the sock is black or white? So again, the denominator is going to be 21. What should I put in the numerator? Or what should my probability be? Yeah, 16 out of 21. Excellent. Toughest question of the whole day right here, this last one. What is the probability that Jackie draws one sock and it is white and black? Yeah, because we're only drawing one sock. It cannot be both black and white at the same time. That would be a 0. That would be a 0. All right, so that's the end of the notes for today. I'm going to take care of attendance here in just a moment. Any questions?